So this is Marty. I'm going to be doing the video today. This is elastic potential energy and power. So I will be able to understand Hooke's law and power. We're going to be taking notes from a video, work independently on a project, and discuss with groupmates. So we're talking about Hooke's law. So when a spring is stretched, there's a restoring force that is proportional to the displacement. The larger the displacement, the larger the restoring force. So we have F equals negative kx. The spring constant K is a property of the spring given by the change in force over the change in displacement. So there's some work done in stretching a spring. So when the work is done on the spring is positive, work by the spring is actually negative, which is pulling back. So from Hooke's law, F equals kx, work equals the area of the triangle. So area equals 1/2 base times the height. So that's why we get work equals 1/2 kx squared. So here in our example, we have a 4 kilogram mass suspended from a spring, producing a displacement of 20 centimeters. So the stretching force in a spring is the weight, which is 4 kilogram mass. So here we have 4 kilograms times 9.8 because we have to turn it into newtons. So our change in force is 39.2 newtons. And if you notice, we change from centimeters to meters, and thus we have 0.2 meters, where our spring constant is 196 newton meters. So we already know that we have 196 newtons per meter, and we're going to stretch it from 0 to 30 centimeters. So we have our equation, work equals 1/2 kx squared. So 1/2, 196 newtons per meter, and then the 0.3 meters, which is transferred from centimeters to meters squared. So our total work is 8.82 joules. So the work to stretch an additional 30 centimeters is greater due to a greater average force. Our next topic is power. Power is defined as the rate at which work is done. So we have work over time, or mgh over time. So our units of power is a watt. 1 watt is 1 joule per second, and 1 kilowatt equals 1,000 watts. So 1 horsepower is work done at the rate of 745.7 joules per second. So to relate power to velocity, we can also get that power is equal to the force times velocity. So here's our example. We have a 900 kilogram elevator at a constant speed of 4 meters per second. So our mass is 900 kilograms. We multiply it times 9.8 times our velocity of 4 and 35.3 kilowatts. And that's it. So this was Marty helping you out.